want to talk about binomial distribution and how that ties into probability. This is going to be used when you have two outcomes, a success and a failure. So when we talk about binomial, four things have to be true for us to start with this. We have to have a fixed number of trials, which means going into it, I have to know exactly how many times I'm going to run the experiment. Let's say, for example, I'm answering multiple choice questions. I have to know that there's 20 multiple choice questions on that. So in this case, my n value would be 20. We'll talk more about that in a second. Each trial has to have two outcomes. If we're talking about multiple choice test, we're talking about correct answer, not correct answer. Outcomes must be independent of each other. If you get question 1 right, it doesn't affect getting question 2 right or wrong. And the probability must remain successful throughout. So let's look down here at our formula. If you look at this very beginning piece right here, that's just combination. That's just this. The P stands for the probability of success, the Q is the probability of failure, N is the number of trials or questions in our case, and X represents the number of successes you would expect. So let's say you're taking a 20 question multiple choice test and you have no idea anything, so you're just guessing. There's 4 choices for each one, so you have a 1 in 4 chance of being correct. That would be my probability of success. My probability of failure would have to be 1 minus that number. And let's say I want to know what's the probability that I'm going to get 7 questions right out of 20. Well, then my X value would be 7. So then I would just plug those into the formula and set that up. Let's look at an example. So in this particular case, a survey found that 1 out of 5 Americans say they visited a doctor. So my probability of success is going to be 1 out of 5, or 0.2. This means my Q value must be the 0.8. 10 people are selected. There's my N. Exactly 3 will have visited a doctor last month. All I'm going to do is go to my formula and plug in. 3 people out of 10 I'm choosing. Probability that someone goes to the doctor is 0.2. I want 3 people to go to the doctor. The probability that people don't go to the doctor is 0.8. If 3 are going, 7 are not. Take my time, put that in the calculator, and then end up with that probability, 0.201. If I want as a percentage, I can say about 20% of the time. If I selected 10 people at random, I would expect exactly 3 of them to have visited the doctor. Let's go to a different situation. In this problem, we're actually going to talk about, what if we're still talking about the 10 people? We're still talking about 1 out of 5. So my probability of success is still 0.2. My probability of failure is still 0.8. And my N is still 10. Same from the last problem. But now we're going at most 1. So my X value is going to be less than or equal to 1. Or I can say it as X is 0 or 1. So I'm actually going to have to set this up as 2 scenarios here. The probability that 0 people visit, and the probability that 1 person visits. I'm just going to add those together. So when we're talking about this is the probability that 0 people out of 10 will go to the doctor. This is the probability that 1 person out of 10 will go to the doctor. Well, this number ends up being 0.017. This number ends up being 0.268. So the probability that at least, at most, one of them will go is right there. Well, if we go to the next problem, it says more than 1. So now my x value is more than 1. We can also say that this is 1 minus the probability of x less than or equal to 1. I know that number. So to find the answer here, I would find the complement, and that would be my answer to part B. Still talking about the same idea as binomial, but now we're dealing with this at most, more than, at least, things along those lines here. The last thing we're going to look at with binomial distribution is how do we find the mean, the standard variance, and the standard deviation. All we're going to do in this case, and this will probably make a lot of sense to find this number here. If I roll 480 times, and I'm looking for the number of 2's that will be rolled, well, the probability of rolling a 2 is 1 out of 6. Well, if I roll 480 times, I would expect 1/6 of them to be 2's, so I would expect to get 82's. Think of it using a coin. If I were to flip a coin 100 times, you would expect 50 heads and 50 tails. Same exact idea. In that case, you're multiplying 100 times 1/2. In this case, it's your number of rolls times your probability of success. Well, variance is still going to use the 480. It's still going to use the 1/6, but now it's going to take that 5/6 into account for Q. This is actually going to end up giving me 66.6 repeating. But we don't do much with variance. So to find my standard deviation, I have to take the square root of the variance. So I end up with 8.165. Do the same thing down here. 8,000 births, 2%. So I have an n value of 8,000. I have a probability of success of 0.02. This is going to give me 160. So if there's 8,000 births, I would expect 160 to be twins. Find my variance. I take the n, divide the p, divide the q. It's going to end up being 156.8. I take the square root of that, which means my standard deviation is 12.52